Alright, hey, what's up guys? It's going to be a quick one. Let's start off with the joke. A statistician has his head in the oven and a bucket of ice on his feet. Why is he doing this? Because on average, he's just about warm. Right? Alright, so let's go ahead and do this. So I've written up the problems for A and B already. Here's A and here's B. What you can do is go ahead and pause this video, and if you want to try it, you can work it out, but essentially what I'm going to do is I'm going to work this out for you guys. I do need to see that you wrote down the questions as well as the answers. Okay, so go ahead, if you need to write this down, go ahead and pause the video and write these things down. And now I'm going to start working it through. Okay, so on the left for A, I see that I have a mean of 13.636 and a standard deviation of 5.85. Okay, so if my mean is 13.636, that's somewhere like over here, and I have a standard deviation of 5.85, that means I need to go somewhere like 18-ish. That'd be like over here. Okay, and then to the left, that would put me at something like 8 something. That put me like over here. Okay, so let's calculate it. One to the right. So it would be 13.636 plus 5.85. I'm going to go ahead and use a calculator so I don't make a mistake here. So let's pull up a calculator. It's going to be 13.636 plus, oh man, I already messed up. 13.636 plus 5.85. That puts me at 19.486. So I guess I was wrong. It should be 19.4 or something. So let's see. It should be right here. Okay, that's going to be 19.486. Alright, so that would be one standard deviation to the right. Okay, now we go the other direction. So let's do that direction. And now it's going to be a subtraction. So it's 13.636 minus 5.85. And that puts me at 7.786. 7.786. Alright, so that's one standard deviation to the right and left of this thing. Okay. What numbers are included within one standard deviation? Well, it would be these numbers: 11, 13, 14, 15, 15, 15, 16, and 19. Okay. How many? Well, how many numbers is that? Is that 1, 2, 3, 4, 5, 6, 7, 8? There's 8. Find the percent of numbers included within one standard deviation. That gives me 8 over 9, 10, 11. 8 over 11. Let's calculate 8 over 11 as a percentage. 8 divided by 11. That gives me something like 72%. Okay, now here's my question, is that if it's 72%, is that necessarily 2/3? Not necessarily, right? 2/3 is something like 67. But when we have less numbers, it can't be as accurate. That's one thing. The second thing, if your standard deviation is really off, an example that might be something like this. For example, if you had something that was this shape, because this one's close to normal, but if it was something like this, right, like a left skew, and you had the mean right here, and you said, okay, I calculated standard deviation, I'm going to go to the left, I'm going to go to the right. You're going to have some sort of troubles here because it's not perfectly symmetrical. If you look over here, there's not an equal amount of people on the other side. So that's one example of where, you know, maybe you captured more people than you intended to. Instead of 2/3, you captured more because it was not normal. So maybe this one isn't normal, okay, but it's pretty close. It should be close to 2/3, which is like 67%. So, you know, in this case, I'm going to say that it looks about right. But if you have something weird, for example, if you take standard deviation and you get something like 90-something%, then something's wrong here. It's not really normal. Okay, so that covers A. For B, it just goes here. The test scores are mean is 85 points. Test score standard deviation is 6. To get an A+ on the test, you must score 1.5 standard deviations above the mean. Well, all you have to do is take 85, and you're going to add the standard deviation, which is 6, and you're going to multiply that by 1.5. So it's going to be 85 plus 9, which gives you 94. So you need at least 94 points on the test to score an A+. To get an F on the test, you just go the other way, 85 minus 6 times 1.5. That's 85 minus 9, and that's going to be 76. So if you score 76 in this case, this leads back to like if you have those college tests. If you score 76 points on this test, you have an F, right? And standard deviations normally won't be that small in classes of 200, 300 people, or you're going to have more variability because there's not going to be a ton of people that just only score 85 points or close to 85. There's going to be a little more variability. This is a very special example where everybody did really well. So if you did poorly compared to everybody else, then you deserve an F. Okay. All right. So kind of short video today, and that's it. All right. See you guys in class.